So in 6.1, we learned about a point estimate for the population. We have point estimate, either the mean or proportion. In 6.1, we learned about point estimate, which is the mean, estimating the mean of a population.
Oh, it's easy.
Instead of having just one point estimate, we're interested in having a lot of different point estimates to give us this freedom to have a lower limit and upper limit. In between, we can select or choose or estimate the population mean. What we learned how to form level of confidence and using that to find critical values, and finally, it helps us to find margin of error and form the confidence interval. Very well. We learned that if sigma or the population standard deviation is given, that's how we find the margin of error. I expect you to ask, what if sigma or population standard deviation is not given? In this case, you're going to use a T-table. 6.2, T-distribution. So in many real-life situations, the population standard deviation is unknown. Population standard deviation is denoted by sigma. If population standard deviation is missing, you're going to use T-distribution instead of Z. So if the distribution of a random variable like X is approximately normal, then T is defined as X bar minus mean divided by S over square root of N. Remember that S is sample standard deviation. So when population standard deviation is unknown, instead of using sigma, we use T-distribution and S. In this case, critical values for T are denoted by T sub C. First of all, the mean, median, and mode of T-distribution are equal to 0. The first property of a T-distribution. The T-distribution is bell-shaped and symmetric about the mean. The total area under the T-distribution curve is always 1. The tail in the T-distribution are thicker than those in the standard normal distribution. The standard deviation of T-distribution varies with the sample size, but it is always greater than 1. When we're dealing with T-distribution, we have to find the degrees of freedom. The degrees of freedom, sometimes denoted by df, are the number of free choices left after a sample statistic like X bar or P hat is calculated. When you use a T-distribution to estimate a population mean, the degrees of freedom are equal to n sample size minus 1. That's how we calculate degrees of freedom. As the degrees of freedom increase, the T-distribution approaches normal, standard normal distribution. Degrees of freedom is 2, so as you can see, the graph is a little bit up shifted. If degrees of freedom is 5, as you can see, our graph is getting closer and closer. The tails are getting closer and closer to the horizontal axis. And as degrees of freedom are getting very big, larger, you get a almost standard normal curve. So remember that when you have Z, you use ZTable. When you have T, you use T-table. Just look for a T-table in Google. Let me show you. T-table. Yeah, let's look for a PDF. Okay. This is a good one from San Jose State University, T-table. So a T-table is like this. First column is degrees of freedom. On the first row, you have T sub 50%, T sub 75%, T sub 80%, and so on. One tail, when you have a one tail graph, 50%, 25%, 20%, 15%, 10%, and so on. When you have a two-tailed graph, 1, 50%, 40%, 30%, 20%, and so on. The intersection gives you the critical value. We're going to go over examples to feel comfortable about this. Very well. Example 1. Find the critical value T sub C for 95% confidence level when the sample size is 15. Sample size, or N, is given. It is 15. You know your confidence level is 95%. So you can form your degrees of freedom n-1 or 14. Now you look at your T-table. With level of confidence 95% and degrees of freedom 14, the intersection is going to be 2.145. So your critical value is 2.145. Let's take a look at the graph. T-table doesn't have any negative value. T-table is always positive. So you found a positive T value, critical value. You put a negative sign in front of it and you have the second critical value. Next, how do we use T distribution and form confidence interval? Very well, the guidelines are the same. As before, you have to identify your S, or sample standard deviation. Why is that? Because sigma is not given. Sigma is the standard deviation of your population. So instead of sigma, you're going to use S and T distribution. When do we use T distribution? When sigma is missing. Find sample statistics, or X bar. Identify the degrees of freedom, n-1. Identify the level of confidence, and then use your T-table to find TC. After finding TC, you can find the margin of error, which is the product of TC, critical value, and S divided by square root of n. After that, your confidence interval is x bar minus margin of error, x bar plus margin of error. X bar minus E, comma, x bar plus E. This is the guideline. Example 2. You randomly select 16 coffee shops. So what is your N? N is 16. And measure the temperature of coffee sold at each. The sample mean is 162 degrees Fahrenheit. So mean of the sample, guys, keyword is sample. Mean of the sample is given. So X bar is given 162. With a sample standard deviation, again, keyword, sample standard deviation, 10 degrees Fahrenheit. So S is also given. Construct a 95% confidence interval. Very well. Are we going to use ZTable or T-table? ZTable or T-table? We use ZTable if we have sigma. Since sigma is not given, you cannot use your Z. S is given, sample standard deviation is given, so we're going to use T-table. Very well. First of all, we need to find our critical value. Degrees of freedom is 16 minus 1. Degrees of freedom, n minus 1. 16 minus 1 or 15. And we have 95% confidence level. So let us take a look at our T-table. Confidence level, 95%, and degrees of freedom is 50. 2.131. 95% confidence level and 15 the degrees of freedom. The intersection is 2.131. That's your critical value. You have positive critical value and negative critical value. But to form your confidence interval, you don't have to worry about the negative one. The margin of error is TC, critical value, times S, which is 10, divided by square root of N, which is 16. So 2.131 times 10 divided by square root of 16, if you do the algebra, is about 5.3. Now, we subtract and add margin of error from the point estimate, which is your sample mean. Your goal is to estimate the population mean. So that's why you have to use your sample mean. X bar minus margin of error, 162 minus 5.3, which is 156.7, and X bar plus margin of error, 162 plus 5.3, which gives you 167.3. So the mean of the population is between these two numbers. You are 95% confident that the population mean temperature of coffee sold is between 156.7 degrees and 167.3 degrees. continue. Constructing a confidence interval. Very well. So here you randomly select 36 cars. We have 36 cars. So N is 36. So the question says the sample mean is equal to 9.75 with sample standard deviation 2.39. Construct a 99% confidence interval for population mean. So you should be asking if S is given or sigma is given. We don't have any information about our population. The only thing you know is your sample standard deviation is 2.39. So to form confidence interval, we have to use T distribution. T-table. Very well. So N is 36, degrees of freedom is 36 minus 1 or 35. The confidence, level of confidence is 99%. If you use your table, you find critical value to be 2.724. Now you can form your margin of error, which is TCS divided by square root of N. Critical value times S, which is your sample standard deviation, divided by square root of N. Margin of error is 1.09. So by adding and subtracting margin of error from the point estimate, which is sample mean, we find the lower limit and upper limit for our interval. It means that we are 99% confident that the population mean is between 8.66 and 10.84. So in general, if sigma or population standard deviation is known, you use ZTable. If it's not known, you have to use T-table. The general guidelines to direct you which table to use. Take a look at example 4, choosing the standard normal distribution or the T distribution. So what do? You randomly select 25 newly constructed houses, so N is 25. The sample mean construction cost is $181,000. So, okay, this is 25. And the population standard deviation is $28,000. Assuming construction costs are normally distributed, should you use the standard normal distribution, the T distribution, or neither to construct 95% confidence interval for the population mean construction cost? Okay, first of all, is sigma given? What is sigma? Sigma is population standard deviation. Do you have that? Population. Here you have the keyword population. Population standard deviation is given. So there is no point using T distribution. We use ZTable to form our confidence interval. 6.3, point estimate for population proportion. What if the question says, estimate the population proportion? In this case, we can use a point estimate, which is proportion in our sample. Sample proportion denoted by P hat is X over N. X is the number of successes in the sample and n is the sample size. Remember that q hat is 1 minus p hat. In chapter 3, we learned about p, we learned about q, q the failure, q is 1 minus p. Let's take a look at one example. Finding a point estimate for population proportion. In a survey of 1,000 US teens, 372 said that they own smartphones. Find a point estimate for the population proportion of US teens. Okay, perfect. Let us follow the formula for sample proportion, which is x over n. X is 372 and n is 1,000. You just do the division and you get your sample proportion, and you say that, hey, since I have the sample proportion to be 73.2%, I can conclude that the population proportion is also close to this number. Please take your time. If you have it. Very well. Okay. How do we form a confidence interval when we are working with proportion? First of all, for proportion, critical value is always coming from ZTable. Margin of error is equal to ZC times square root of P hat, Q hat divided by N. And P, or the population proportion, is sandwiched between P hat minus E, P hat plus E. One example. Question says, construct a confidence interval for P. So we're using information in the first example to form 95% confidence interval for population proportion for US teens who own smartphones. So in example 1, we learned that P hat is 0.3072. Q hat is equal to 1 minus 0.372. So Q hat is 0.628. We check the conditions. NP is greater than equals greater than 5, NQ is greater than 5. And now we form the margin of error. Remember that for 95% confidence level, this is 95%. We use ZTable. So your ZC is equal to 1.96. We plug in the values and the outcome is 0.030. Your confidence interval, P hat minus E, P hat plus E. P hat, which is 0.372 minus E, P hat plus E, 0.372. So the lower limit and upper limit is equal to 0.342, 402. What's the meaning of that? It means that we are 95% confident that the population proportion of US teens who own smartphones is between 34.2% and 40.2%.